All right, 6.3 Law of Cosines. Notice these are crazy looking formulas, very similar to the Pythagorean theorem, especially the c squared equals a squared plus b squared. In fact, the Pythagorean theorem is considered a special case of Law of Cosines. These are all saying essentially the same thing. You have segment A, and B again, but the C, the angle C, is in between those two. Just like the area formula from the last section, this is set up with this format, side angle side. So all three of these are essentially saying the same thing, side angle side. In fact, the labeling becomes irrelevant if you keep this in mind. Let's use that and go ahead and solve for these here. Personally, I don't even think about these formulas. I just go ahead and plug in my values, and if this is the variable, say B is angle B, then I would just plug in my segment B, segment A, segment C, and A and C again there, and just solve for B using good old Algebra 1 skills. All right, so let's go ahead and find the three angles in this triangle. I'm going to solve for C first, just because it's my preference. So I have C squared is equal to A squared plus B squared minus 2 times A times B times cosine of angle C. It takes some practice to get this straight in your head, but notice this is just side, angle, side, and these are just those two sides again. And this is the other side right here, other side. That's all that's going through my head. Now it just comes down to simplifying and solving. I'm going to do some algebra and some arithmetic all in one step. 14 squared is 288. I'm going to subtract away 8 squared. 19 squared, I do not know the square of in my head, but it's 361. Oops, not 188, I apologize. 196. And this is divided by 2 times 8 times 19. I just like to do a little simplifying as I go. That's 304, and this is equal to cosine C. So it's just cosine, or inverse cosine, making sure I'm in degree mode, of the 196 minus 64 minus 361 divided by 304. And I get angle C to be roughly 138.87. Now, once I've got one of the angles in this triangle and I have some sides, notice we would have a complete ratio, a proportion set up to be we can solve for the other two angles. We could solve for B and A using law of sines. We could also use law of cosines. My personal preference is to use law of sines, if at all possible, because it saves some hassle with some arithmetic. But that's pretty much all it is, the law of cosines. Then it just comes down to making sure your syntax is correct, making sure you type things in, or plug things in correctly, and do your algebra nice and correctly. So I'll just do a couple more problems to make sure that you got a firm foundation on this. Notice they've given you the law of cosines in this case. A squared equals B squared plus C squared minus 2BC times cosine of A. I have the values in the triangle drawn out for me, so I just need to plug in and go like this. A squared is the unknown value, so it's equal to 15 squared plus 10 squared minus 2 times 15 times 10 times cosine of 115. Notice all we have to do is type this in and square root both sides, and remembering that this is plus or minus, but we're solving for a side length, so we only keep it positive values. So I just type it in one swift move in my calculator. 15 squared plus 10 squared minus 2 times 15 times 10 times cosine of 115 degrees, making sure I'm in degree mode, and I am. So I get my A to be approximately 21.26. And it says find the remaining side lengths, so we're done. And the remaining angles, same case. Once you get one of the angles, just use law of sines and cosines to find either of the other two angles. My preference would be to use law of sines. Application problem, still pretty much the same thing as before, so we can do those. We're going to do a lot of these in class, in fact, and I think this time it's going to be just a little bit shorter video. Heron's formula, sorry about the bell. Crazy looking formula. We have side lengths, or it's not side lengths. This is S, and S is defined as what looks like the average, except this is 2, not 3. Honestly, I think this is a bit crazy. The proof in this, a little bit extensive. We might go through it in class. What I like to do is take my A, B's, and C values and stow this into C in my calculator, and then type it in just like I see it here. It helps me make sure that my syntax is correct in the calculator. So we'll do some of those in class, but it's pretty much all it boils down to when finding the area of an oblique triangle using Heron's formula. That's it for this video.